Today we're going to use Desmos to calculate the tangents at a point of a function. And in the limit, of course, we recreate the function itself. Let's start by defining a function of x, which in this case, let us say that is x squared plus x. And the next thing we're going to do is to create, well, the delta of x, which is going to be, it doesn't have to be a list or a slider in this case. Uh, in fact, well, all right. Well, let us define it as a hard constant so that we avoided creating a slider, and we're going to make it very fine. Well, it's not letting me do it anyway. So we go to 1, and then we go up the way to 0.1 with the step size of 0.1. Right. So we have created the delta x or h, which is or is going to be useful for defining the derivative. And then we define the derivative as follows. Suppose we have d of x, another function that depends on the former, which is going to be equal to f of x plus h, and then we subtract the function of, x, and divide by h. And this has created a linear function which we are not going to use, but it's obvious that the derivative of a quadratic function is a linear function. So the next thing that we need to do is to create a list. In this case, I'm going to call it a equal the square bracket, and when we're going to begin from negative 3, comma, negative 2.75, comma, and the ellipsis, which indicates a pattern. Well, in this case, Desmos is going to consider it a pattern because we have indicated how it's going to progress. In this case, it's going to go every 0.25 all the way up to 3, positive 3. Right. Nothing is in because that's something like a variable stored in the memory. And we need also to define the intercepts for the tangent points. It's going to be y of a equal the evaluation at every point in A the next thing we need to do is to define the slope, and the slope is of course the derivative evaluated at every point of A, right? And then in order to construct the linear functions, well, we have already the slope, the intercept, so in this case, well, we need to give it to another variable. So m equal, actually I'm going to give it a label so that we know what we're talking about. Equal d of this. All right, so now that we have that, define our variables that depend on these different lists and functions, we can create the tangents, which are y, all the family of linear functions define y equal m sub index a, which multiplies x minus a plus the intercept. Uh, right? And then we have it, all the tangents. But if we would like to see the the tangent points, okay, well, we create all of these points, a, comma, and then y of a. And then we have it, all the tangent points of all these uh, tangent lines to this quadratic equation. And that would be all for today.